Hello everyone, welcome to day 2, lecture 1 of NCERT Geography. So before we begin the lecture, just some basics that I want to tell you that entire syllabus that we are going to cover in these NCERT modules, that is NCERT of Geography, Polity, History and Economics, will lay a good foundation on which we will be covering even more detail when we study the books. So we are going to cover the basic foundations, basic facts, and some value addition things also as well, along with the NCERTs in this module. If you have any doubt, you can just comment on the comment in the comment section that is given just to the side of this video, or you can connect with the mentor directly and have a 20-minute slot if you have any in-person doubt. That would be a one-on-one session with me, and I can clear any of your doubt. And this session can be booked at any time during the entire preparation. So let's start. So we are studying the English module, day 2, lecture 1 of NCERT Geography. The topic that we are going to cover today is about the basic facts, starting from the very universe. What is universe? What is universe? What are the galaxies? What is a star system? What are planets? What are satellites? Such things. And we will be ending up with what is nuclear fusion that happens on our sun and other stars, and what is the difference to it with nuclear fission, and such other facts, why Earth has life and other planets don't, and how do we predict that any planet that is thousands of years away from us can have life. So you might be reading some of these news in the newspaper that scientists have found a planet that there might be a life on it. So we will be answering all these questions because they have been asked in previous year paper questions, especially UPSC, if I'm saying for this video. So let us start from the very basic. So first we will be building a detailed analysis, and within which I will be explaining you many facts. So our first thing to analyze is what exactly is the universe. So universe, in simple terms, I could just say that it is collection of galaxies. Collection of galaxies. See, you might have seen the images of James Webb telescope that were released by NASA some time ago, which has, peeked through the past and how the universe has formed and how it is expanding. So basically, we will be covering these theories in detail, but just for a beginning and just for a beginner's understanding. The universe at the very beginning was a single atom that we can say that it was singularity. The entire system, the all stars, gases, planets, everything was just in a single atom. We call it singularity. This is according to the theory of Big Bang, about how the universe actually formed. So we are explaining on that front. So suddenly, so there are two types of materials, matters to say, in the entire universe. That is a matter and an antimatter. So I'm giving you a technical side of it. It is not in the NCERTs. So I would be putting in some extra information just for the understanding, so that you understand these concepts well in detail, so that we have a solid foundation. See, there are two things in the universe: matter and antimatter. Matter is what creates things, and antimatter is what destroys things. So at the very beginning, matter and antimatter existed in equilibrium. Any number of matter that is created had the equal number of antimatter that was being created. So they collided with each other and the effect was nullified. After many tries, centuries of the universe, what happened is there was one extra matter created. So for which there was no antimatter, just one extra matter created. This matter was singularity. So singularity is a single dot that had all the universe, all the even our solar system, our Earth, in a single dot. So this is considered the densest part of the universe. If we can see till this point, we will see this is the highest point of density in our entire universe because everything was packed in a single dot. So density as a concept we will be studying in further lectures as we see what is inside our Earth and how our Earth's surface is arranged. But for just a basic crux, density is how close are particles packed to each other. Consider iron and wood. Wood and iron have different densities. Iron is more dense than the wood. That's why iron cannot float on water. It always sinks, while the wood is capable of floating on the water because there are spaces in between it. So has air has occupied these uh, empty spaces. So that is why they create a floating surface, but not in the iron. That's why it sinks. So density is anything that is how closely things are packed. So this is the basic concept of it. So seeing the singularity, pardon me. So what happened is from the singularity, suddenly the things started to expand. And they are still expanding. The universe is still expanding. More and more galaxies were created. There were star systems within them. Dust and clouds were also created. So the entire universe is still expanding. So this is the basic crux of the entire theory. We will be studying this theory in a very detailed manner when we cover it in the geography portion, because there can be questions from it either in prelims exams or mains exams. So we will consider it to be an important theory, and we will be having a very detailed discussion when we go through this in the main geography subject portion. So just for the context, so the other thing that we have been taught wrong since the school days, school has taught something wrong that most of the students around India are taught in a very wrong way, and even NCERTs mention it in an incorrect manner or unclear manner. That's why the teachers in our schools are also not teaching us properly. That we are often told that the entire universe is a vacuum. So beyond our Earth, the entire space, it's a vacuum. This is a false fact. The real fact is the universe is made up of 90%. The 90% of universe is hydrogen and helium gases. So obvious reason we can't breathe in these gases, but the universe is not empty. 90% of the universe, the space in it is filled by helium, hydrogen, and rest 10% are the planets, stars, dust, and other gases as well. Some of them even poisonous gases. So the universe is not vacuum. Please correct this basic error that many of the students have been taught wrong in the school, and over the years I have encountered it. So I like to make it clear that this is a wrong fact. Because why it is important? Because nowadays we are, expanding the horizons of human species. We are thinking of traveling to other planets. We are sending our satellites far away from our Earth to, Saturn, Uranus, Neptune, not India, but NASA per se. So they are communicating back. So anything, so all the communication, all the radio waves and everything, they cannot travel in vacuum. They have to travel through some medium, that is air, that is present in our solar system as well, or even beyond our solar system. So we haven't been able to go beyond that till now, except from the telescopes that we can see. So this is the basic crux of it. So after the universe, the next question that comes in our mind is, what are galaxies? Because if universe is collection of galaxies, what are exactly galaxies? So let me show you an image of how galaxies, collection of galaxies look. So we'll be building on it. Grab an image of it. And so whenever I will see from a telescope, if I get a very clear image of the universe, what I would be actually seeing is an image like this. If you could say, I will just zoom in. So these all are different galaxies. This is a different galaxy. This is a different galaxy. This is a different galaxy. And if you will look closer, they have different shapes. So if you will see, this has a some sort of this shape. This is a disc shaped. This is round. So they have different shapes. They have different movements. They have different number of stars in them. So the entire universe is filled with these galaxies. One of these galaxies is our galaxy, which is our galaxy. I'm just marking it randomly. Not This is not per se our galaxy. I can mark anything. That's for this. Our galaxy is Milky Way Galaxy. So just to have a scale of how far us humans are actually from exploring the space in person, not through the telescope, but in person, that we are on just one planet, that is Earth, which is part of a star system, that is Sun, which is a part of a galaxy that in itself contains thousands or even lakhs of stars. So thousands of stars, one among them is Sun. So there are many galaxies like this all around the universe. So that also creates a question that that also answers one of the question that we might not be the only, civilization or only planet in the entire universe that has a life. Because I don't think we humans are that lucky that, in the entire universe, we are the only one who could actually have a life, or Earth is that lucky that it can have a life. There might be different lives, different forms, but they're there, they exist. So we don't know how advanced they are. We haven't communicated with them. But as we explore more, we might encounter them and find them. So now the next question is, what are galaxies? If I go on to answer this in a simple way, galaxies are actually, as I told you, collection of star system. So we don't simply say the stars, we actually say star systems. There's a logic behind it. Because even if you see our solar system, why we call it a solar system? Because sun is not the alone a single object that is present in our entire system. There are planets, there are asteroids, comets, floating rocks, dust, gases. So as a whole, we are, you know, together in this system, which in itself has a main component that is a star, that is a sun, and around it we all exist. So that is why we call it a star system. So if you will see our galaxy, let's first have a look in at our own galaxy, and then we will proceed further. Collection of why we call it star system. So this is Milky Way Galaxy. This is the image of Milky Way Galaxy. So if you will see the Milky Way Galaxy, it is spiral shaped. The entire galaxy is spiral shaped. It contains all the stars. If you look closely, these white dots, these are the stars. So one of them is sun. Let's say this is sun. Sun has its own planets, asteroids, Kuiper belt, and everything. We will be drawing all of these in a while. But even sun is on a path. It is revolving. All the stars are revolving until they reach the very center of it. So if you will see the center of it, it's very bright. It's all white because all the stars come near to each other in this place and they start to collide. And when they collide, there are many huge blasts taking place. And that is why this area gets so brightened up. There are constant blasts that are happening in the very center of it. But around it, if you will see, sorry, this is the path that the sun has to cover. So don't worry about it. Sun is not going to come to this stage for many millions of years. So we are still on the outer periphery. So there are a lot of years for the humans to actually find a way to go to any other planet or any other star or whatever path we will find. But this is the motion, the natural motion that is happening within a galaxy. So moving on to the next terminology. I just told you that galaxies are collection of star systems. So the main thing in it is stars. Our star system, as I've told you, is solar system. All right. So that means that next to galaxies is a star system, or to say our solar system. It is collection of planets. What is a star system? I will first write a definition and then I will explain you. It is a collection of planets, the satellites, meteoroids, comets, rocks, dust, and gases. So I will explain to you all these things. We will be drawing the solar system and breaking down all these things within that. First, we need to actually, work on two terminologies before we proceed further. Those are what is a rotation and what is a revolution. So what is a rotation and what is a revolution? If I see this is, let's suppose this is any planet. For that, let's suppose it's Earth. If I draw an imaginary line from the very center of it, it is called axis. In a vertical side, if I draw an imaginary line, it doesn't exist in the real world, but as an imaginary line. So when any object, even if you remember, there was even a cartoon show used to come on the TV, Beyblade and everything. So anything that spins on its own axis, it is just spinning on its own center of point, that is spinning around, it is called rotation. It is not going around any other thing. It is rotating on its own axis and on its own points, just going round circles. This is called rotation. So when any object spins on its own axis, it is called rotation. Coming to the revolution. Revolution is a motion when, let's suppose, we have sun at the very center of our solar system. When a body goes around another body, again, let's suppose our very own Earth, when a body goes around another body on a path, this path is called orbit. All right. So it's a fixed path that it would be covering. So any object, supposedly, that goes around another object, that motion is called revolution. When one body goes around another body, so that is revolution. When there is one body and the other is doing circles around it, this is called that this body is doing, this is actually revolving around it. In a even closer context, we have our own body that is near to us. That is, if you can obviously guess, that is the moon. See, the moon is our natural satellite. Satellite as a terminology is any body that revolves around a planet. We call it a satellite. So we have two types of satellites. Let's discuss this concept here only. We have two types of satellites, that those are natural and artificial satellites. Natural satellite, for the Earth, we have only one satellite, that is the moon. And for the artificial satellites, we have around 5,000 satellites surrounding the Earth. And we have also sent other satellites to other planets, like the Mangalyaan that we have sent to the Mars. And we are still launching other missions, like we are sending satellite in few years to Venus as well. So these are some of the planned missions. NASA and China, they have also sent satellites, rovers, and many other missions to the Mars. So these things, they actually, even the satellites that we are launching around the Earth, they're just doing circles around the Earth. That is why we call them that they are revolving around the Earth. Anything that goes around another object, that motion is called revolution. And if that motion is around a planet, then anything that is revolving around it, we call it a satellite. All right. So now the next question that should come in our mind is breaking down in all these things, what are satellites? So let us differentiate between what is a star. If I ask you, what is a star? And secondly, what is a planet? How will you differentiate between the two? What is a star? What is a planet? So the difference is not that tough. If we'll look directly to it, that one of them has its own light and the other is dependent on the light of the other. So we obviously know that, like in our very own solar system, we have a sun, and on the other side, let's suppose we have our Earth. First and foremost difference between these two is that sun has its own light and heat, while the Earth depends on the light and heat of the sun. Sun, that is a star, because we are studying what is a star, right? So that's why I'm writing in a bracket. Secondly, as we have studied, the Earth, planets revolve around the star. So, like the Earth revolves around the sun, the satellite revolves around the planet revolves around the star. So, the question is, does the star also, do the stars also revolve? Yes, they also revolve. They revolve to the center of the galaxy. Stars also revolve to the center of the galaxy. Like I have showed you before, that all the stars are going in circle till they reach the very center. So this is not a fixed orbit, because they are moving closer and closer to the center, and ultimately they will merge together and there would be a huge blast. But this is still a round motion, that is why we call it a revolution as well. So please remember this. This can be a statement in any of the prelims exam. So you have to remember this. See, many of the questions that come in the prelims exam are based on the general knowledge that we should have. You don't need to actually remember the heavy facts. What is the distance between this and this? What is this? What is this? If you know the actual existence and the reason why it is happening, you can answer most of the questions. So most of the questions in the civil services exam are based on the reason, and this is why it is. All right. So moving next, let's draw a diagram of solar system. So this is a sun. Let's keep it in the center. So just taking a minute to draw all the orbits around it, so that you can have a good explanation about it. Make this orbit a bit short so that we have more space. So how, till the time I'm drawing it, feel free to answer a few of things. How many planets are there? I will be answering these things. How many planets are there in the solar system? And we used to have a planet before, which is not included in the list now. What is that planet and why it is not included? So even if you don't know the answer, I will be giving you the answer. Please do comment after that, so that I can also get a gist of things that you are understanding, the concepts that I'm teaching you. All right. So moving next. 4, then let's leave a bit of space here. 5. 6. 7. This is the eighth one. All right. So we also have a belt of rocks present here after the first four planets. We call it asteroid belt. It is full of small and big rocks. Some of these rocks are as big as even our planet or of the size of the Mercury, say, and to almost 3/4 of the size of the Earth. So, similarly, there is also a rock belt at the end of all these planets. That belt is called Kuiper belt. Let me I'll just mark a single line so that we can complete it a bit faster. Here we go. Yes. So we have two belts of rocks, that is Kuiper belt and asteroid belt. So the next question that I have for you is, after the star system, the next definition that we have is what are actually planets? Because we have written, planets, we have studied what are satellites there, ones that are revolving around the planets. We will be studying the meteoroids, meteors, meteorites that will come in a while. I will be telling you what are comets, but um, uh, but what are the rocks? In this case, the rocks of asteroid and Kuiper. Let me tell you one more thing that we have been taught wrong in the school, that we make a very clean diagram when it comes to solar system, but the solar system is actually not that clean. We don't have like a very straight line for the Earth, very straight line for the Mercury, and there is nothing that comes in between them. So there are two things that I have already told you a bit, that there are two things that are present in the entire universe, that is dust and the gases. Gases occupy a very big space in the entire universe, as well as our own solar system and the galaxy as well. So we can actually, whenever you see all these images from the telescopes, you can actually see these gas clouds being pointed out. They have a specific name for them. I will show you the image as well of the gases and how they are seen in these images. So then you would be able to relate to them. If not now, the next time you see them. I will show you the latest images from the James Webb Telescope. Uh, See this, if you see this diagram carefully, this image carefully, this is from the James Webb Telescope. You see all these bundle of gases. These are all gases. You will see different colors around them. This blue color that is here, some green and brown colors. So these are different gases. And whenever they receive light from the stars, the particles inside them, they just charge up, and the energy that is received from these stars and that charged particles have to release the energy, so that you have studied this concept in the school chemistry class, where any electron, when it used to gain energy, it has to release that energy to actually get back to its own orbit. So what it did is to release energy, and energy can release only by four methods. That is through heat, light, sound, and uh, heat, light, sound. Oh, sorry, only three methods. Yeah, heat, light, and sound. Heat, light, and sound. The energy is only released in these three manners. So what these gas clouds do is the electrons in these gases, because every gas, we have a chemical formula, they have their own set of electrons. Whenever they are charged, they will start releasing the energy. So when they release energy, they produce these lights around them to discharge the energy. That is why we have these different colors around in the entire universe. The entire universe is shining just because of these gases receiving the light, getting charged, and then discharging their entire energies. All right. So that is why we can see such images. These gas clouds are called nebula. Nebula are the gas clouds that are present in the entire universe. So the images actually look like this. So the next thing that I was telling you is the entire universe is not empty. There are other things like the dust as well. So what has happened over the millions and trillions, the billions of years that the universe has existed, that many rocks have collided with each other. Either they have, later stick together, or both of them have collided so badly that they have been broken into smaller pieces. These pieces then again collided with each other or with some other pieces, and soon they became dust that has not settled anywhere and is floating around the universe. The same is true for the solar system. The entire solar system is not this clean. All the planets that we have, let me make some planets. There's a Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The last planet that we used to have was Pluto. And why it is not in the list, I will tell you shortly. First, let me answer this. So, this system is not that clean. There are many small rocks that are present in the entire solar system as well. We also see these small dots, these small, what to say, these small rocks at night that we often call them shooting stars. So I will tell you about when I tell you about meteoroids and everything. So our entire solar system is not very clean, and there is dust present in the entire solar system as well, because there were many other planets, and even these rocks, asteroids, they still collide with each other. Kuiper belt rocks also collide with each other. They are still creating more smaller rocks, or they are merging to make even a bigger rock. So what is the difference between these rocks? If I'm telling you that some of these rocks are of the size of the Mercury or almost the size of even the Earth, why don't we call them the planets, and we are calling them just the rocks of the asteroid belt and Earth or any other things as planet? So to qualify as a planet, you need to have your own unique orbit. So everything has a fixed orbit when they revolve around another thing. But for a planet is one that has a unique orbit.
That is that no other big object, there are many small objects in between them, but there is no other big object on their path that is also revolving on the same orbit. Any object that is able to clear its entire orbit and has no imminent danger that it is going to collide with another big object on its orbit is called a planet. The difference is that the asteroid belt is full of such rocks. They don't have their own unique orbit. They are sharing a single orbit altogether. Same is true for the Kuiper belt. And this is the reason that we disqualified the Pluto. Pluto was actually at first thought to be a planet that had its own, you know, unique orbit. But as our observations gotten better, we found that the Pluto was lying in between the Kuiper belt. So actually, it didn't have its own unique orbit. There is an international body that is the International Union uh, this astronomical first one. Yeah, IAU, Astronomical Union. That's why I wanted to consider. International Astronomical Union, IAU in short. This is not a governmental body, it's a scientific union where all the scientists which are who are working in the field of astronomy are part of this organization. Whatever research they do, whatever objects they find, they present to all their peers in this union, and once it is verified, it is given a name. So that is why whenever you see a new planet or new object being found, you will always see they have such names: X21b8. So these are the scientific names given by the scientists. So these are not verified till now. Then they are presented to IAU. IAU will verify the facts, and then they are given different names, and we call them by the names that we can remember. Or many of the objects are still in the scientific name. If we consider them that, immediately humans might not need this information at large, because names are given actually for our commoners, the people like you and me who are not into astronomical research, so that we can actually remember these names, we can talk about things, and we can actually generate the scientific curiosity. Because remembering such names, be tutu or anything, something, this is a tough thing for humans. That is why we simplify them, and then we call them planet Earth, planet Venus, Mercury, or even the stars like sun. So this body is the one that considered the case of Pluto, and they were the one who later disqualified Pluto as a planet after all the research debates and everything. So that is why now we have 8 planets which are moving in this motion, and a solar system exists like this. All right, so completing this definition of planets. So see, let me tell you one thing, like before I complete the definition. Like Earth, we have our own atmosphere, we have gases around the Earth, we are breathing the oxygen. Earth as a whole has nitrogen as the gas that is most present in quantity around our Earth. There are other planets like Mars that has carbon dioxide as its majority component gas. So such large objects like the Earth, they actually attract many gases around them, and that creates an atmosphere. Even the sun has its own atmosphere that is filled with hydrogen and helium. Those gases are very reactive, and that is why specifically hydrogen, that is why there are many blasts, nuclear blasts that are happening on the sun, and that is creating the heat and light that is coming from the sun. I will be discussing that in a minute. So same is the case with many asteroids as well. Many large rocks have their gases around them that is creating atmosphere around them, but the only thing is that they don't have a unique orbit of their own. That is why we don't call them planets. This is the only difference between these rocks and the planets, that the planets have their own orbit while asteroids or even Kuiper rocks don't have. All right, so the definition of planets in simple terms is that it is a bundle of rocks, like we have a solid surface and gases which have planets which have their own unique orbit around a star. So this is the basic definition of planets. This is how we categorize different things, starting from the universe to the galaxies to star system and planets. We will be building up even more on the Earth as a planet, and we will be also discussing how universe formed, how our solar system formed. There are theories to it, which if you are going to take geography optional for the UPSC or any other state services exam, so you have the option of taking geography optional. You will be studying those theories in very detail. Otherwise also you will be studying them for your general studies paper, because they can be asked in the prelims and the mains exam, but we will be covering them in the geography subject. So let's work on our foundation first. All right, so this is this is our solar system. So within our solar system, now there are few definitions that we need to work on. See, we have studied that the sun is the one that is producing heat and light. So in general terminology, the sun is spreading the heat and light to a very large distance. Heat might be limited to some distance, but the light could be seen to a very far distance. There might be some other civilization with better telescopes. They might be seeing our star, our sun, and they might be naming it something else. So there has to be a limit to which the light will go, after which it might not be seen. It would just turn dark. Because if as a general experiment also, if I have a flashlight and if I point to a very far open field, there would be if a person is standing just next to me, he would be seeing it as a very bright light. But as the person moves away, he would be seeing the light getting dim, getting smaller, and after a while he might not see the light. So the light will just vanish away into the darkness. So same is with the sun. Its light would spread to a very specific areas. So whatever area this light is covering, the entire circle that is covering the sun's light is covering, we call it heliosphere. So you always remember this word, even we will be using in the world history and other subjects. Helio always represents sun. So whenever we are using helio word, it is sun. So sun's sphere, sun's area of influence, wherever its light can reach, it is called heliosphere. And the area where its light ends is called heliopause. So it has ended. This line where it ends is called heliopause. So you can, write these definitions as well as I'm speaking. Heliosphere is two. Heliosphere is the entire area to which the sunlight reaches, and heliopause is the boundary that is formed by this, beyond which the sunlight doesn't go. So heliosphere and heliopause. Other than that, we have, so we can divide all these planets into two parts. One which are between the sun and the asteroid belt, and one which are between the asteroid belt and the Kuiper belt. These planets are smaller in size and are called inner planets. I'll be making this diagram a bit dirty now because I have to explain many things in this. So please pay close attention on understanding the concepts. You can actually read some extra information that is given below this video, and you can also go through the N.C.E.R.T topics that are mentioned above. So these are the inner planets. All these four planets, the Mercury, Venus, Earth, and the Mars, these are the inner planets. They are smaller and they're mostly made of rocks, minerals, and metals. Then they're the outer planets, which are also called Jovian giants or gas giants. These planets are very big in size compared to the inner planets, and most of their area that forms around them is actually gas. That is why we call them gas giants, because most of their area is covered by gases. That is why their size looks so huge, and that is why we also call them gas giants. So these are mostly, by the name, they're mostly made up of gases. These inner planets are made up of rocks, minerals, and metals. So this is the basic difference between these planets. Now, the next question that I want to answer through this is, why only the Earth has life on it? Why not any other planet? And sometimes you see these things in the newspaper as well, that scientists have found a planet that might have life. And if you see the distance, that planet is hundreds of light years away from us. So how can we actually say, if we can't peek through that planet, how are we actually saying that that planet might have life? So there is a reason, because every star would have its own heat and light. So any planet that is very near to it would be burning with heat. So for the case of Mercury, and even the Venus is very hot. The problem is they are very near to sun. So what happens is, any vegetation that could have been possible on them, or in case of Mercury, it doesn't even have atmosphere, because such is the force of sun that it has faded away all the gas around Mercury. So Mercury is a bare planet, and Mercury's surface is so close to the sun, because and it is, that's why, burning. So there are fires, literally fires, on the entire Mercury planet, and that is why it is very hot. Same is the case with the Mercury. But as we move further away, the planets start to get colder and colder. So even that is not habitable, because if there are freezing temperatures, not many species would actually be able to survive, and not many natural resources would be produced in such planets. So such is the case with Mars and the planets beyond it. So there is actually a sweet spot for every star. There is a sweet spot, a habitable zone, where the life is possible, because this area is neither too hot nor too cold. it has the optimal temperatures where the life can exist. So this is now our luck that the Earth falls in this area. The Earth is in this habitable area. This area is called Goldilocks Zone. The official terminology of it is Goldilocks Zone. So this is also a previous year paper of UPSC. They had asked what are Goldilocks zones. So you had to explain that this is the habitable zone. This was a prelims question. So this was the option that it is a habitable zone on which within which the life is possible on the planet. So when we also make discoveries from far away, for far away planets, that planet might have a life, we are actually looking at these habitable zones. So what we do is, what we see the star of it, we see the size, the intensity, the light of that star, the heat of that star, and then we do the mathematical calculations at what distance a habitable zone would be formed. Once we have that zone, then we start calculating, okay, if there is, then we start to find if there is any planet between that habitable zone. And if we find any planet between that habitable zone, then we make this conclusion that this planet is actually, this planet can actually have a life on it because it is in a Goldilocks zone. So please remember this terminology, very important. And easy to remember, so not a very tough concept. Next, we have a planet. We have, so I'm considering an Earth. I will tell you what I'm making. We have our atmosphere. This is Earth. So Earth. Sorry. This is our Earth. So we have our atmosphere around it. Atmosphere has different layers. So I've tried to represent these. What I'm teaching you now is what are meteor, meteoroid, meteorite. See, these are three definitions depending on the rock where it is present. So if a random rock is just floating around the solar system, it is called meteoroid with ID. It is randomly floating in the space, has nothing to do with the Earth, just floating around in space. Sometimes these rocks could be very small of a rock. They come in the path of the Earth, and because of that, they enter the Earth's atmosphere. So whenever they enter the Earth's atmosphere, they go through high friction because the air around the Earth would actually produce friction between them, and that causes or sets them on fire and breaks them down. So whenever a rock, just make some rock so that it is not lost like this. So whenever a rock enters our atmosphere, we change the terminology and we call it meteor whenever it enters atmosphere. So we often see these rocks enter the atmosphere. You might have seen them in the night. They are called the shooting stars. Shooting stars. All right. So they're called the shooting stars. So if you have seen them in the night sky, you would have just seen that they get burned in within few seconds of you watching them. So because there is such a huge friction in our atmosphere that they are not able to sustain their size for a very long time, and they get completely vaporized within seconds on entering the atmosphere. But sometimes the size of these meteors is quite large, and they're able to strike the Earth's surface. If they strike the Earth's surface, it would be a very big bang. If it's quite a big uh, rock, sometimes there are, meteorites falling that are size of a hand as well, but they would have still a lot of energy in them, and if anything comes in their way, it would obviously be destroyed, because they are coming at a very great speed. If they are able to reach the Earth's surface, we change their name to meteorite. We call them meteorite with TE. So D and T, don't confuse them. So whenever they reach the surface, all right. So whenever they reach the surface, so whenever they strike the surface, the next thing that is that, if they are of very big size, the dinosaurs on the Earth actually were finished by an asteroid that turned into a meteoroid that fell on the Earth and led to all the volcanoes on the Earth burst out suddenly, because that was so much pressure on the Earth that the entire lava present inside the Earth, that it just bursted out. That destroyed the dinosaurs. So they could be very large in size, like the one the dinosaurs faced, or they could be large enough, to make their presence felt on the Earth, like I will show you in this diagram. So this is a site where an asteroid might have struck at some time during the history of the Earth. So this entire dug up was made when an meteorite hit the Earth. We call this pit crater. And sometimes these craters, they get filled. If there is a river nearby, the river might fill it. If there is underground water, it might fill this area. Or with the rain, this large area might get filled. If such areas filled, we call them crater lakes. India has a very famous crater lake in Maharashtra, that is the Lonar Lake. You can search it on Google, Lonar Lake, Maharashtra. That is a crater lake. At some point in the evolution of the Earth, and a meteorite might have struck the area that is Maharashtra right now, and that has created a hole like this, in which water has filled up, and now it has created a lake, that is Lunar Lake. All right. So this is how these things evolve. Now moving ahead, let's talk about what is actually happening on the sun and how it is producing its heat and light. So what is happening is the nuclear reactions. So before, what is happening on the sun, the nuclear reactions are of two types. One is fusion and one is fission. Fusion is a reaction when two atoms, they come together and they merge to form a molecule. So what is happening on the sun is there is hydrogen atoms come together, they merge and they form helium. This is what is happening on the sun. The other reaction is the fission reaction, which is when a molecule breaks down into two atoms. Whenever bonds are formed or bonds are broken, energy is always released. This is the energy that we use, or the sun, produces, that we receive as heat and light. So this is the energy that our life is dependent on. So fission is when a molecule breaks into two. This is the technology that we use in a bomb, then what we call our nuclear bombs, or I'll just write simply bomb because nuclear is at the top, and also at a nuclear power plants. Now, these both energies have their own benefits and negatives. Fission that we are presently using, it actually produces, but its downfall is, produces radioactive material. Radioactive material is something that is continuously discharging its radiations, which destroy the cells of any living material that is present around them. So such material cannot be thrown away in the environment or in the oceans, or else it will destroy the entire life in that area. So this is the problem. Fusion energy doesn't have this problem. Fusion energy is very clean. So if we are able to make nuclear power plants of fusion energy, we will have unlimited electricity, unlimited source of energy without the worry of any radioactive material. But the problem is fusion reaction is uncontrollable as of now. Scientists are still working on it, and it might be possible in the future, but right now it is uncontrollable. And that is why if any reaction goes wrong, it might burn down entire cities or even our entire planet. So, and these are the reactions that are happening. So next thing is, whenever there is a blast, if you have seen the videos of nuclear blast, or if you haven't seen, you can actually, mm, surf around YouTube and just look at the video of any nuclear blast. What you will see is, whenever a nuclear blast happens, there's a mushroom like cloud being created, and then there are powerful winds that are striking, that are moving outward in all directions. Actually, these are not just winds, these are charged winds. So these are electromagnetic waves that are being thrown out. When sun, because there are quite a large size blast taking on the sun, that is why whenever a nuclear blast happens on a sun, we have a special name for it that is called solar winds. So we have named it winds, but it's not actually a wind. It is an electromagnetic wave that is, spreading all around as a force. So because these are waves, whenever it strikes, it feels like it's a wind, but these are charged particles. If I, keep any electronic device on its way, its circuits might burn down. Any dead battery might get charged up. So they have charge in them. So such solar winds that are coming from the sun, these are so powerful that they can actually destroy the entire uh, electronic industry that we have on our planet Earth, whatever electronic devices we are using. And most common victim of, uh, these solar winds are actually our satellites. So there are satellites, which, get toasted up. Their circuits are burned out whenever a solar storm takes place, whenever a large blast takes place, and these winds are very powerful. So whatever satellite is on its way, it just gets toasted away because it's all circuits are burned down. So these losses are very common. But a planet, so the problem is that there is a possibility that someday these solar winds might reach the Earth's surface, and they might destroy all the electronics, our entire power grid, and everything that we have. And they are so powerful because, I've told you that they feel like wind because they have their own push. They're so powerful that they can even take away our entire atmosphere with them within seconds. So right now, like, we are breathing the air, we don't actually care much about the air around us, but within seconds the entire air might be gone, and we might be suffocating to death. This is actually a reality that scientists, often consider about. So what is happening is our Earth has a natural mechanism of protecting itself. How this mechanism is formed, we will be discussing in further lectures. So consider Earth a natural magnet. It has its north and south magnetic poles from which magnetic field is being created around the Earth. What this magnetic field does is, so magnetic waves always go from north of the magnet to the south. So this is how the magnetic waves travel. So these are the charged particles. The solar winds are the charged particles. Whenever these charged particles try to come near the Earth has its own mechanism that it realigns these electrons on its magnetic path, and by making them travel long distances, soon they are able to discharge their extra energy. And I have told you that extra energy is always discharged either as heat, light, or sound. So in this case, light is produced. So that is why the poles of the Earth, where these lines are, where these magnetic lines come closer to each other, because there are poles to it, we often see these electrons discharging their lights as different lights in the sky. I'll show you. This is a very beautiful scenario that is often seen in the polar areas. See this. The entire sky gets lit up. So electrons in this photograph, see, if you can see, they have a direction to it. This is the magnetic direction. So the charged particles from the sun are traveling along the magnetic field of the Earth, and as they are traveling, they're losing their energy, and while they lose their energy, they are producing these different colors depending on the energy they are containing. They have these different colors. These colors are called, this phenomena is called auroras, auroras, auroras. And it is very common in the polar areas during summer season. So you can also see their video as well from the YouTube. It is always better to see these concepts. So you can just go and search this concept on the YouTube, auroras, and you can see a video to it, how these are moving. These are all the charged particles that are coming from the sun. That is why we are seeing them like this. So this was our first lecture to the NCERT geography. I'll see you in the next lecture with more concepts as we build on the geography. Thank you and see you. Thank you.